Good morning, class. We're looking at section 4.2. Sorry I couldn't be there today. And this is SSS and SAS are the two theorems that we're going to be looking at. So far, what we've looked at in section 4.1 was that 6 pieces of 2 triangles need to be congruent in order for the triangles to be considered congruent. So we could say that in this particular picture, we're looking at triangle ABC and triangle DEF, trying to determine if they're congruent. And if they are, then I can put my congruent symbol in there. Okay, so as we look at these, I'm going to slide down just a little bit. And the 2 triangles, basically what's needed, if you look down here on the bottom, I wrote down the 6 pieces. 3 congruent sides and 3 congruent angles. And they have to be corresponding sides and corresponding angles. As they're listed, they have to be congruent in the same sense. Okay, so AB would be congruent to DE. Remember how they're listed? BC would be congruent. So if I'm looking at this, AB would be congruent to DE. BC would be congruent to EF. And then AC would be congruent to FD or DF. So as you look at this, AB, excuse me, that's the wrong one. AB is over here. AB is congruent to DE. That's true. BC, that's this one, is congruent to EF, and that's this one, and that's true. Okay, and then AC is congruent to FD or DF, and that's true as well. So by this picture, those 2 triangles are congruent. So if I go back up to this congruent symbol that I've got at the top here, then that means that these 2 triangles are congruent. Okay? That's what we're looking at. So basically what's needed is I need 3 pieces, and we've got 2 different theorems here. Postulates, I guess. So I'm looking at postulate 4.1, and postulate 4.1 says that side, 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 or SSS postulate, if 3 sides of one triangle are congruent to the 3 sides of another triangle, then that's enough information for me to tell you that the 2 triangles are congruent. Okay? So if AB is congruent to DE, and BC, or segment BC, is congruent to segment EF, and segment AC is congruent to DF, those guys right there, then that's enough to say these 2 triangles are congruent. Okay? So using side, 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 given LM is congruent to NP, now you're looking at your picture, it's this guy right here, so if you need to blow it up, blow it up. I can make it a little bit bigger, but LM is congruent to NP, and they've got that marked here, okay? And LP is congruent to NM, and that's marked here. Prove LMN is congruent to NPL. Okay, so, sorry about that, getting my diagram here. So what I need is, I need 3 sides, all right? I've been given on my statements and my reasons. I was given LM is congruent to NP, and that LP was congruent to NM. Okay, and that would be given. Okay, so let's see if I can get this here. So 1, and then 2, well, that's 2 of the sides. I need the 3rd side, so 2. That LN is congruent to itself, or is congruent to NL. Okay. And that would be by the reflexive property of congruence. Okay, so that's true because it's congruent to itself. All right, now I have 1, 2, 3. I have enough I have enough information now with those three sides to say then that triangle LMN is congruent to, and I'm going to have to write it down here, triangle NPL, and that would be by the side postulate. Okay, which is what we just looked at. That's enough information. Those three give me the equivalent of the 6 in the previous one. Okay, if you need to slow this down at any point, you can hit pause and keep going, but I'm going to keep moving. On this particular triangle, you have been given that BC is congruent to BF, CD is congruent to FD. To prove then that triangle BCD is congruent to triangle BFD. All right? So, take a look at it. Set yourself up with your statements and your reasons, okay? And see if you can't prove this one. Okay, hit pause. All right, so the statements that are given would be BC is congruent to BF, CD is congruent to FD, and that's by givens. Okay, the second one, here we have a BD is congruent to itself, or DB, and that again is by that reflexive property of congruence. So that we can say that the two triangles BCD is congruent to triangle BFD by the side postulate. Okay, so there's one of them. 3 pieces are enough to tell me that all 6 of them work, or all 6 of them are congruent. On the second one then, postulate 4.2. This one's a side angle side postulate, which is sometimes referred to as the hinge postulate. Okay, whereas I've got 2 sides and the angle between them, which is almost like the hinge. If 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, and you'll notice they're all right next to each other. Okay, side, angle, side, angle, side. They have to be in that consecutive order. They can't hop around the triangle. Then you have enough information to say that those 2 triangles are indeed congruent. Okay? So using side, angle, side here, what other information would be needed to prove that these 2 triangles, DEF, that's the top triangle, and that's this triangle up in here, and FGD, which is this triangle down here, is enough to say by side, angle, side, these are congruent. Okay, so we have a side here and a side here that's marked. Those are congruent. We have the side that is shared, and that one is one that I don't need to have stated to be able to use. It's the reflexive property, and we can always see that. So I have a side and a side. What I would need is between these 2 sides down here, I'd need that angle, and these 2 sides up here, I would need that angle. So the information that I need then is angle EFD is congruent to angle, let's see, this would be GDF. Okay? So if I had those, then that would allow me to say that these 2 triangles are congruent. Oops, sorry. Get that out of there. On this one, what information? Go ahead and hit pause in a second, but what information do you think you'd need to prove that these 2 are congruent? LEB and triangle BNL. All right, so as I'm moving on, that angle is given, and again, this side is given. So I would need then that this side and this side would be given. So I would need that LE is congruent to NB. or BN. Okay, let's erase that. So, okay, so LE is congruent to BN, and that one would actually be B. Okay, I hope you got that. Go ahead and keep moving. Identifying the two congruent triangles here, would you use side angle side or side to prove that these two triangles are congruent? Well, look at your markings, okay? So you get a side marked side, 1 and 2, and an angle between. So we would be able to say that side angle side, because it's two sides and the included angle or the hinge between those two sides is congruent. On this one down here, I'm looking at those three and those three. Don't just look at the symbols, because I see 1, I see 2, and I see the angle. But notice that for the first angle, these guys, it's included, but this out here, problem, this one is not included. So these are not. There's not enough information here. They're possible that they're concluded. I mean, it's possible that this particular angle up here and this angle down here are congruent, so that you have an isosceles triangle here. That's possible. We don't know it. We don't have enough information. So, explain your answer. There's not enough info. And these pens are hard to write with. Okay, not enough info. And then finally on this one, C, side angle side or side. And I've got side. I would say definitely side. And that's enough information there. Got all three sides marked and down below. Then the final one. So on choice D or problem D, you have 1, 2, and 3. So this would be side as well. Now, you could also use side angle side, because of those two angles I just circled in here and here. Those guys are vertical angles. And remember, I don't have to have those marked. Vertical angles are congruent. So I could have also used side angle side. So you have enough information to use both. All right? Hope that was helpful, and hope you're having a good week. I hope to be back to you just as soon as I possibly can. All right? Take care. Bye.